I thought I should do another problem for you from this chapter. So I have taken a one which has dependent sources in it. So both current sources, but you can have an idea of how to handle dependent sources in a circuit. Remember, a dependent source is not a source that has energy in it. So a dependent source is allowed if you are to find transfer function of a circuit, but here we are not interested in finding the transfer function. Here this voltage is V2 with reference to this node, and the question says find V2 at t is equal to 1 millisecond, the value of this voltage at 1 millisecond, and assume there is no initial energy stored in all the circuit. So no initial energy in the L's and C's. So how to do this? Again, converting a circuit, such a circuit, to a frequency domain. Let us convert it here. Or in fact, we can probably save redrawing the circuit. In the exam, you can actually save redrawing the circuit, but here I am doing it for you. So this sign does not say it is a sinusoidal source. It is just a variable source, so it is 14t applied at t is equal to 0. So what will be the Laplace transform of 14t? That would be 14 over s square. 14t ut is 14 over s square. Here a resistor of 100 ohms and a capacitor or an impedance of 1 over s 600s. Since it is in microfarad, it will become 10 raised per 6 here, and another capacitor of 500s, and an inductor 2 milli, it will be SL, so 2 into 10 raised per minus 3 S, and then we are going to have the two dependent sources drawn as is. And remember, this now voltage becomes capital V2. So the Laplace transform of 3 a constant and V2 t function in time domain will become 3 V2 of s. That's it. So it will just be written as 3 V2, not 3 V2 over s. A lot of people do this mistake. Why they do this is unclear, but that's very important. V2 t is a function of time. Its Laplace transform is V2, and 3 V2 would have the Laplace transform 3 capital V2 and 5 capital V2, and that's simple. Don't commit this mistake that all sources are going to have ut with them and therefore they will have 3 V2 over s and 5 V2 over s. That's wrong. So you do it this way. Now since we need to find this V2 and we have an essential node in here as well, I believe that we can we have no other easy option except that we assume this to be V1 and use node voltage method to write the equations at least. So V1 minus 14 over s square over 100 plus 10 raised per 6 over 600 s plus the outward current would be minus 5 V2. The outward current would be minus 3 V2 plus V1 minus V2 over 10 raised per 6 over 500 s is equal to 0. One of the equations, and the second equation at V2 would be the outward current is 5V2. The outward current is plus V2 over 2 into 10 raised power minus 3 S plus V2 minus V1 over 10 raised power 6 over 500 S is equal to 0. Since this is a circuit in the book, it should not be too complicated to solve, but solving it on video is going to lengthen the video for no reason, but let me try to go forward a bit. So here we can have the LCM 600S and take it to be multiplied or we can say that we multiply, okay, let's do it this way. So we have 600S in the numerator with V1 minus 14 over S square over 1000, in fact 60,000 S plus 10 raised power 6 plus minus 8 V2 plus 500 S V1 minus V2 over 10 raised power 6 is equal to 0. So 5 V2 plus 1000 V2 over 2S plus 500 S V2 minus V1 over 10 raised power 6. So V1 common, 600 S over 6 into 10 raised power 4 S plus 10 raised power 6 plus 500 S over 10 raised power 6 minus V2 8 plus 500 S over 10 raised power 6 is equal to 14 into 600 over S into 6 into 10 raised power 4 S plus 10 raised power 6. This goes to the other side. And here we get minus V1 500 S over 10 raised power 6 plus V2 5 plus 500 by S plus 500 S over 10 raised power 6 is equal to 0. Let me just pause the video and see how quickly I can reach a amicable value so that I will get back and continue the video. Well, I have tried to simplify it, but probably it has either I have made a mistake or it has become very complicated. So basically, from this equation, I found V1 equal to this thing, and then I put it here instead of V1. Um, I put this thing here, and then took this V2 common to get this thing, and the constant goes to the other side, and then these then further simplified it, this denominator on this side and this side is equal, so it cancels after taking this LCM here, and I have gone to this side. I may have made a mistake, but because I think that uh, this term should simplify to a single term. This is 600 and this is 1800 times per 4. It's too big a difference for this to be subtracted properly. So we are going to get a square term here, s term here, and a constant here, which obviously we were going to factorize and then take the partial fractions and then simplify it further. However, because of this minus sign, I believe there is some mistake. Is not identifiable. Anyway, the basic idea is clear. Okay, let me have a look whether this particular question has an answer at the end. The answer is going to tell us if we expect a simpler expression or not. We don't have answers at the end of this PDF that I have. This is the end chapter problem 20. So if someone of you redoes it, please have a redo at it and see if I have committed a mistake, then post on the Google Classroom so that we can completely solve it. I will do it once again, and if I find a mistake, I will post about it in a further video.